guys, have your notes for 2-3, day 2 pulled up. And what we're going to do, I'm not going to teach you anything new today. We're going to take all the vocabulary, all the information that you learned yesterday, stuff about leading coefficients, end behavior, factors, zeros, multiplicity, all that, and we're going to put it all together, and I'm going to have you graph a function that you probably never thought possible to graph because it looks so complicated, but we're going to do it all completely without a graphing calculator. Now at the end, I will pull up my graphing calculator and show you how to check to see if the graph that you drew on your paper does match the graph on your graphing calculator. But that's at the very end. That's the way we're going to check it. We have a lot of work to do, and you have a lot of work to show before we get to the point where we're going to graph it on our graphing calculator. So the first one we have is a cubic, and it kind of walks us through how to graph it. First of all, use the leading coefficient test to look at end behavior. Find the zeros, find the multiplicity of each zero, find the turning points. Get a few extra points to see the true shape of the graph, and then sketch it. So here I go. For part A, looking at my function, my leading coefficient is -1, and my function is a cubic. So my end behavior is going to look like this. Next one, find all of the zeros, part B. Now, usually if we're in a normal teaching and learning situation, usually this is like an activity that I have you do in class so that you all are coming up with how to solve it. If all you do is just watch me set it equal to 0, watch me factor it, watch me solve it, you're never going to get to the point where it becomes your idea. This is how I'm going to do it. So that's a bummer. I'm having to show you, and you're taking my word for it, and you're copying it on your paper. Kind of a bummer. So I set it equal to 0. I notice that both terms of my function have an x, and my leading coefficient was negative. So I chose to pull out -1x. When I pull out -1x, I have two terms left. My first term is a positive x squared, and my last term is a -9. So I'm going to solve both of these factors. So these are both factors. Let me highlight that. That's a factor. That's a factor. Okay, it's not this isn't a linear factor. I could go on to say x plus 3 and x minus 3. Those would be linear factors. I just chose to straight up solve it from here. Okay, so I've got 3 solutions. I've got a solution that comes from here, x equals 0, and then I've got 2 solutions that come from here, positive, -3. So I went over to my graph, and I went ahead and plotted my zeros. There, there, and there. For multiplicity, each 0 occurs only once. How do I know that? Well, I have 3 zeros, and it's a cubic. They have to occur once. If one of them occurred more than once, let's say that this one, you thought maybe this one occurred more than once, then here would be like 2 zeros, and here would be 2 zeros, and that's not possible because it's only a cubic. Okay, so each 0 occurs only once. That means that at each of my locations, at each of my zeros on the graph, my function will pass through the x-axis. Now, according to my end behavior, and turning points. Let's talk about turning points real quick. Whoa. Since my function's a cubic, there can be up to 2 turning points. Now, according to my end behavior, this is what I think my function kind of looks like. I think that it's like coming in like this, going down like this. think that it's going to pass through here. Somewhere it's got to turn and come up and hit this 0 and pass through. And then somewhere here it's got to turn and pass through this 0 and head on down. Well, how far down do you want me to draw it before it turns? You don't know, but you can get a pretty good idea. So I think that it probably turns close to halfway between these 2 points, don't you? I think it probably turns like somewhere here. I just don't know how low to take it. And then same thing here. It's going to pass through. How high do I take it? I don't know. But I know that from a horizontal standpoint, I think it's going to turn about halfway between those points. I just don't know how high. So what I'm going to do is I am going to take these 2 x values. This one's about 1.5. This one's about -1.5. And I'm going to plug them into my function. Okay, so I'm going to plug this x value in and see what I get for a y. I'm going to plug this x value in and see what I get for a y. I did that, so here we go. When I plug in 1.5, positive 1.5, I got positive 10.125, a little bit higher than 10. And when I plugged in the negative 1.5, I got negative 10.125, a little lower than negative 10. So here's what that tells me. When x is 1.5, y is a little higher than 10. When x is 1.5, y is a little higher than 10. Holy moly. I was thinking about turning it right here. No way. Not good enough. I need to go all the way up to a little past 10 and then turn it and come back down. And then same way down here. When x is negative 1.5, y was like negative 10, just a little more than 10. So I was thinking about turning it like here and sending it back up. Oh, no. I got to come all the way down here before turning it and sending it back up. Ooh. So that's what my cubic looks like. Now, let's check it on a graph. So I've got my graphing calculator pulled up. All right, here we go. The first thing that I want to do is I want to make the graph settings on my graphing calculator match the ones that are in my notes. So in my notes, this graph that we drew on, if you count out your x's, it went as far left as negative 10 and it went as far right as positive 10. The y's went from negative 10 to positive 10. So that what I'm looking at on my graphing calculator looks similar to what I have on my paper, I want to get my graph set up the same way. So if I push window, I can see what my settings are at. My x's start at 0. This is just, I don't know, the last time I graphed something, I chose these settings for some strange reason. To use negative 10 and positive 10 and to quickly go there, I can just go zoom standard. So zoom 6, and that gets me the window that's going to match my paper. So zoom standard gets you negative 10 to positive 10 both directions. All right, I'm going to go y equals. I'm going to type in my function, negative x cubed plus 9x graph it. Yep, sure enough, that's what it looked like in my notes. All right, going back to the notes. I've got another one. This one's a quartic. And again, you're going to watch me factor, and I wish I could get you to do this on your own. I'd really like to say, pause the video and see if you can do this. Probably 2 people might pause the video and see if they can do it on their own. Doggone it. Oh well, here we go. Leading coefficient. It's a positive 0.5, and F has degree 4, so my end behavior is going to look like this. Find the zeros. So the first thing I did was I set my function equal to 0, and I immediately took out that x squared. When I take out the x squared, here's what I get. Now, yep, you can use quadratic formula. I use quadratic formula as a last resort. Like, I always try to factor first. I like factoring. I'm good at factoring. So I recognize that, ooh, this would be terrible to factor because there's a 0.5 here and a 0.5 here. But what I can do is I can take out a factor of 0.5 or a half. So if I take this term and I divide out a 0.5, this term divide out a 0.5, and this term divide out a 0.5. When you divide out a 0.5, you don't get 1.5. You get 6. If you don't believe me, get out your scientific calculator and do 3 divided by 0.5. So I divided out a 0.5. Look at that pretty quadratic that I have left. That is so factorable. So here are my factors. Yeah, I'll go ahead and do that. This is a factor, this is a linear factor, this is a linear factor. I solve each piece. So when I solve this piece, obviously x had to be 0. Solve this piece, positive 3. This piece, negative 2. I have 3 distinct zeros. 1, 2, 3. But it's a quartic. It's a 4th degree polynomial. So really I should have 4 zeros. I do. This one occurs twice. How do I know this one occurs twice? Because its factor occurred twice. This factor has like an exponent of 1. This factor has an exponent of 1. These only occurred once. This one occurred twice. So my zeros are 0, 0, 3, negative 2. What does it mean that this one occurs twice? That means when I go to graph it, the graph only touches. So it's going to sit on the axis where x is 0. This one's going to cross through. This one's going to cross through. This one's only going to touch. All right, so I've graphed my zeros. Remember, my function is going to cross through here, touch here, cross through here. And remember my end behavior. So my end behavior looked something like this. Right? So what's going on down here? Well, crosses through. How far down do I go before turning, coming back up, and whoa, no, don't pass through. Turn, come back up, and touch. And head back down. And come back up and pass through. Remember, passes through, passes through. Multiplicity is 1. Only touches. Don't let it go through. So it's got to pass through, touch, head back down, pass through. How far down do these go? Pick a number in between and find out. So let's go halfway between these two. I'm going to choose x equals -1. Let's plug -1 into our function. Halfway between these two, I'm going to choose positive 1.5. Let's sub in 1.5 and see what I get. So part D says sub in values and I chose, let's see, -1 was halfway on the left side, 1.5 was halfway on the right side. I sub those in and I get a y value here of -2 by subbing that in, and I get -5.9 or so by subbing this in. So -1, let's go down to about here, and let's say -6. 1, 2, 3, 4, 5. Let's go down to about here. Let's go pass through, turn, touch, turn, pass through. That's what it should look like. I'm going to go to my graphing calculator. I'm going to clear out the cubic, and I'm going to type in my quartic, 0.5x to the 4th. Nice. Looks like the one I drew. So your homework on this is going to be a worksheet. When you're completing your worksheet, you have a lot of work to do before you pick up your graphing calculator. So keep in mind, you need to show all this work, graph a rough sketch, and then instead of going to my website to pull up the answers, or instead of, it's not my math lab, so you're not going to get that automatic, good job. Check it on your graph. I'm expecting you to check your own answers, check your own graphs on your own graphing calculator. No, you won't be able to use your, wait a minute. I don't think that's a true statement. You do need to be used to getting this, you need to be able to do this on your own. I do think this is going to be a graphing calculator test when we get done at the end of the chapter. So, but again, make sure you show all this. Make sure you know what you're doing.